Homework here for our vectors. Given a vector in component form, find the vector's magnitude and direction, and write it in polar form, which is the magnitude followed by the angle. So number one, this is going to be a vector. We could draw it as a vector in quadrant 1. 4 to the right and up 5. If we draw a reference triangle for this, to find the magnitude, we're going to use Pythagorean Theorem. So the magnitude of A is going to be the square root of the x's squared plus our y squared. Our x is 4, our y is 5. It's going to be 16 plus 25. It's the square root of 41. Magnitude of vector A is the square root of 41. How about the angle? Well, for sure, to find theta prime, we're going to do tangent of theta prime is y over x, 5 over 4. Theta prime is going to be tangent inverse of 5 over 4. And that is about 51 degrees. We're going to round to the nearest whole number for degrees. In this case, theta prime is also theta, both in quadrant 1. So that's going to make the direction 51 degrees in standard position. Let's check out number 2. This is going to be in quadrant 2. We're going left 2 and up 9. So the vector might look something like this. If we make a reference triangle for this, we could figure out theta prime. We could figure out the hypotenuse. The hypotenuse to this is the magnitude. Using the distance formula, it's the square root of the sum of x and y components, each squared. So that's a negative 2 squared plus 9 squared. It's going to be 4 plus 81. That's going to be the square root of 85. That is the magnitude. Just go back up here to number 1. I wrote this with these little fellas. This is polar form, which is an ordered pair. Magnitude followed by the angle. So number 2, to find theta prime, the reference angle, we're going to do tangent of y over x. When we do this, we ignore the signs to find this angle, because what we are essentially doing is we're finding this angle in quadrant 1. Then we'll use that reference angle and we'll subtract it from 180 to figure out what the angle is. So theta prime, the reference angle, is tangent inverse of 9/2. And that is about 77 degrees. So if that's about 77, theta is going to be 180 degrees minus 77, which is going to put us at 103 degrees. I think I should write smaller. Number 3 is in quadrant 3. We're going left 11 and down 3. So our vector would look something like this. The x component is 11 left. The y component is 3 down. To find the magnitude of this little fella, it's the square root of the sum of the x and y components squared. It's 121 plus 9. It's going to make this 130. Vector f has a magnitude of the square root of 130. Well, what's theta prime going to be? So when we do this theta prime business, let's imagine that this triangle is in quadrant 1. You can redraw it if you want. The point is we want to use positive numbers for the angles to figure out what theta prime is. Then we're going to use theta prime and add that to 180 to figure out what this angle is in standard position. Tangent of theta prime is y over x. Theta prime is tangent inverse of 3 over 11. The faster I write, the more time it takes, because I have to rewrite. Using a calculator, this is going to give me about 15 degrees. So it's 180 from here to here, and then we add 15 more. Theta is going to be 180 degrees plus 15 in this context, which is 195 degrees. Vector f, components, left 11, down 3. Or you could say I'm going to travel the square root of 130 in distance with an angle of 195 degrees from standard position. Number 4, this vector is going to be in quadrant 4. If we put it in a coordinate plane, it might look something like this. Right 1 and down 7. If we make a reference triangle, then the magnitude is going to be the square root of the square of x plus the square of y. It's going to be 1 and 49. That's going to be the square root of 50. In polar form, this is going to be the square root of 50 followed by the angle. When we figure out this angle, let's just imagine this is in quadrant 1. Which you don't have to do, but once again, you have to use positive versions of this to figure out what the reference angle is. Tangent theta prime is y over x. Theta prime is tangent inverse of 7. Which is about 82 degrees. Now that's the reference angle. This is 82 degrees. So we could say it's negative 82 degrees. If we wanted a positive angle, we would subtract 82 from 360. And that would give us 278 degrees. So using this is fine. We could also say it's square root of 50, 278 degrees. One answer is not better than the other. Number 5, this one's actually easier than most. If we go right 3 and up 4, this is a Pythagorean triple with the magnitude being 5. The angle, theta and theta prime, are going to be the same for this one. It's in quadrant 1. Tangent of theta is 4/3. Therefore, theta is tangent inverse of 4/3. That's going to give us 53 degrees approximately. That's in quadrant 1. The reference angle is 53 degrees. If it's in quadrant 1, the reference angle and the angle in standard position are the same. Number 6, we are in quadrant 2. This looks familiar. If we go left 5 and we go up 12, five squared plus 12 squared is 169. Its square root is 13. This is a Pythagorean triple once again. Should have written this for the last one. Pythagorean triple, 3, 4, 5. Pythagorean triple, 5, 12, 13. So the magnitude of this little fella is 13. What's the angle? Now this angle that we're going to find here for tangent, that's the reference angle. We use y over x, just use the positive versions, figure out what the reference angle is. Theta prime is tangent inverse of 12 over 5. And that, oh geez, that this is a nightmare. This is a mother's worst nightmare. 67 degrees. That is this angle right here. We want to know this angle, so we're going to have to subtract that from 180. Theta is going to be 180 minus 67. It's 113 degrees. All right, hopefully that wasn't too bad for you folks. That concludes the homework for this section.